Welcome guys, on today's tutorial we are going to learn how to create your own graphic interface for a project using Processing and Garagino. Let's get started. To get more information, visit our social web at garagelab.com. To buy one of our products, go to garagelabstore.com/store and don't forget to subscribe at our YouTube channel. So guys, this is the circuit we have assembled on Mini Proto Shield, which is connected to Garagino. In the circuit we have a potentiometer, two LEDs, green and red, and a switch button. The circuit will interact directly with our interface. This means that you can make your own interface for your project and design it as you want it to be, as we are going to see. Firstly, I connected the Garagino to the USB to serial converter, and then I will run the interface software. Now with the interface running, we can see we have a pointer and a graph indicating the position of the potentiometer. I have made with a range from 0 to 100%, but there isn't a rule. You can create any kind of range you want to. In fact, you have all freedom to create your design with the tools more suitable for you. The reason I have created like this is because it's very intuitive. It could be a thermistor indicating the temperature or the percentage of the temperature. We also have two LEDs, the green one on the left and the red one on the right. And we have a button representing the button switch button. So, by varying the potentiometer, we can see the variation on the screen. Our graph varies along with it. Take a look when I placed at 50% of the range. Now take a look at the button. If I press it, you can see the change in the LEDs. If I hold it, the green LED will turn on. If I release it, the red LED will turn on and the green will turn off, both in my circuit and on my screen, as you can see. I can do the opposite as well. I will press the button on the screen. I have disabled the button and both LEDs were turned off on the screen and on the circuit as well, as you can see. Now I click on the green LED and it turns on in the screen and in the circuit. Now I do the same with the red LED. Pretty cool, isn't it? This means that we can create an interface that interacts directly with our project, where we can see what's happening in our process and also control the process using the interface. If you take a look at processing interface, you are going to realize that it's pretty similar to Arduino's interface. That will make it easier to learn and to use this powerful tool. So guys, we have here the assembly on the Mini Proto Shield. As we mentioned before, we have a potentiometer, two LEDs and a switch button. The image shows the schematic, where we have all connections that we have made. The pin D2 is connected to the red LED, the pin D3 to the green LED, the pin D8 is responsible for the reading of the switch button, and at A0 we have the pin responsible for the reading of the potentiometer. This schematic, as well as the codes and other details, you can find on this tutorials page at our social web, whose link follows on the video description. There, we will find all necessary information to reproduce or even change this project. This is the code used by Garagino during the process. I will provide some explanation about it. Here we have the variables used in our software. At void setup, initialize the serial with a baud rate of 9600. Then we set the pins. The pin 2 addressed to the red LED as output, the green LED pin 3 is output as well, and the pin 8 addressed to the button as input. At void loop, firstly I initialize the variable port value, then I will do the read of this variable 100 times. Each time I do the reading, I do a conversion as well from 0 to 180. This conversion makes it easier to send the value to processing. So the processing will just receive a value from 0 to 180 that will represent the potentiometer's position, as you saw in the demonstration. So I read this variable 100 times, then I calculate the average number from these readings, and that average value I will send using the command serial.write. I will send to the processing. After doing this, I do the reading of the switch button. If there was an alteration of the state from pressed to released or the opposite as well, I will verify the variable enables button. If it's true, that is, if my button is enabled, I check if the pressed button has level logic equals to high. If it has, I will store at the variable value sent the value 255. I turn down the green LED and I turn on the red LED. If the logic level was low, value sent will receive 254. I will turn off the red LED and turn on the green LED. And then I will send this value stored in this variable value sent to processing using serial communication. In other words, I'm sending the button state. After doing this, I store the last button state in the variable button state previous to be able to compare if there was an alteration of the state of the button in the looping. I wait for 50 milliseconds and I check if there was something received by the serial. If there was, I store in received value variable. If this value was 255, I change the state of the red LED. If the value 254, I change the state of the green LED. But if this value is 253, the value sent to Garagino when the button in the interface is disabled or enabled, I turn off the two LEDs, reverse the state of the variable enables button, and I can see at the interface if the button is enabled or disabled. If it is enabled, I turn on the red LED that indicates that we went back to the initial state. Now, let's turn briefly to processing code. And this is a code we've used to build our interface. Firstly, we import the serial library. and then we initiate it. Then I created an instance for each image we are using on our software. So we have 8 instances. Each instance name is related to the name of the image inside of the file data. That's not necessary, but I found easier to program as well as explain it this way. Then I created 3 integer variables. The first one received the value that will receive the serial value from Garagino, pot value that will receive and store if this value is related to the pot potentiometer, and finally the bottom value that will receive the value from the bottom. I created 3 Boolean variables as well. Enable button, that sees the button state in my interface. The state LED red, that sees the state of this LED. And I did the same with the green LED. Besides those variables, I created as well an integer variable called adjust. It's meant to help me to adjust the image on the screen, because when you insert your image in your interface, it might not behave as expected. So this variable was created to solve this problem. On the y-axis, at void setup, I select the COM port. I do this by this command, and here is selected by position. So the first position, the COM port 0, is the position of my COM. It's the same position, it's the same COM used by Garagino. So I have to use the same COM port that Garagino is connected. In this case, the COM port 0. After doing this, I initialize the serial communication with its baud rate. I define as well the size of my screen, and then I load the images to the respective instances. Basically, we are getting the images from the file data, as I showed you before. Notice that the images and instances don't have to have the same name. I did this way to make it easier, as I've mentioned before. As you can see, it's all pretty simple. When I need to position the image now, I just have to call their instance, because the images are already loaded. After the setup, we go to void draw. This void draw will work at the same way as the void looping in the Arduino's code, or in our case, the Garagino's code. Firstly, I check if something was received by serial. If it was, I store inside of this variable, receive the value. If the received value is less than 181, I know it came from the potentiometer. So I store the value inside of the pot value variable. If the value is 244 or 245, I know it came from the button, and I stored inside of the variable button value. Then I update the background image. Remember that the background image has to have the same size of the screen you defined before. By using the command translate, as I did here, as the same way I did here, I can define the 0 point at the center of the screen. Otherwise, the 0 point would be placed in the left top part of the screen. When the variable enable button is true, that is, when it is enabled, and if the value received was 255, I put on the screen the image of button off, as you can see. I also put the image of the LED off at the position of the green LED, and I put the image of the red LED turned on. Basically, I select the image and I selected the position at the x-axis and y-axis. So button off is centralized at x-axis. That's why I divided for 2, and in order to centralize it in x-axis. And 125 is the position of the y-axis on the screen of this image. And using the same logic, I placed the other figures, the other images. So here you also have position in x-axis, a negative position in axis, and 50 in y-axis. And that's why it was so important to set the 0 point of the screen at the screen center in order to have a good reference to all these positions. If instead of having 255 we had 354, we put the other image at the same position, the button on image, as you can see on the screen now. I'm showing you is the button is being pressed. Then I put the image of the green LED on, and I put the image of the LED off at the same position where we had before the red LED, the LED red on. The next situation, it is when the button is disabled. I place the image of the button blocked, button not, at the same place where we had the button enabled. At the same time, it releases the option to click on the LEDs in my interface. So, if the LED green is false, I put the image of the LED off. If it's true, I put the image of the green LED. And at the same manner I do with the other LED. If it's false, I put the image of the LED off, and if it is true, I put the image of the red LED. Following the software, we have the potentiometer situation, where we do the command rotate to do the rotation of the potentiometer in the pointer in our screen. But firstly, we have to turn into radians to be able to work with it, and do a conversion as well. So we get the value received from the from Garagino about the potentiometer, and we subtract 90 from it, and then the value is suitable for use in our processing software. So after do the rotation, I put the image of the pointer at the right position, and I have to provide the X and Y position. So I centralized at X axis, and in Y position I put a negative position, negative number, and I added 7 to centralize the pointer here, as you can see on the image. and then the pointer will behave as expected. Finally, but no less important, the void function mouse clicked. This function will rule your mouse throughout your interface. Basically it works by coordinates. So here you have the coordinates of your button. If you click your mouse inside of this square, this area, you change the button state, you reverse the button state, you will send to Garagino the value 253, and you'll turn off the two LEDs. So at the same manner you can apply to the other elements of your interface. So guys, that's it. That's the basics of processing. I hope you have enjoyed this tutorial, and I really hope to see you again right here on Garage Lab TV. See you!